Well, here we are in front of two Peikko projects that are identical, phase 2 and 3 of this Luxembourg project. This one was started last year in August and was occupied by June the following year. It has 2 levels of parking and 5 levels of residential for 55 units. The 2 levels of parking are done also with our system, with hollow core slabs, composite beams, composite columns. And what we have behind us is the phase 3 that's under construction as we speak, that will be delivered at some point next spring. A Peikko frame consists of composite columns and composite beams. What this means is basically the composite column is a hollow section, a hollow steel section with reinforcement inside the column that is later filled with concrete. Same for the delta beam. Delta beam is also a composite beam, so it's a trapezoidal steel profile with reinforcement inside that's later on filled with concrete. And those 2 components support a long span decking system such as hollow core slabs that we have here on this job site, or it could also be a long span steel profile. Here we are next to a composite column by Peikko. So we have the HSS section that's empty at this point. It's only the steel tube with the reinforcement inside. You can see the connection system is very simple on this column. At the bottom we have a base plate with 4 holes, and basically the bolts are projecting through the beam and we just simply sit the column right on it. In this case, we're using a continuous beam system. This is basically to use the negative moment over the connection point, so to allow us to have a longer span with a shallower section. So we have a continuous beam here, and then we have a hinge connection, which will then span from this point to the stair shaft. Here we have a delta beam edge beam that allows for a full view from floor to ceiling. So if you were to have a curtain wall that you want to have a full window from floor to ceiling, you can actually get this with this edge beam that only projects down from about ½ an inch from the hollow core slab. A beam and column system allows for a lot of flexibility for the interior layout of the units. As we can see on the floor where the partition walls will be between units, there's a lot of angles, a lot of layouts are possible because you're not only between 2 load-bearing walls. Anything is possible for the inside. As you can see on this particular project, there's a couple of unique features or special features that is very applicable to residential construction. So we have balconies. On my right here, we see cantilever precast slabs that will be hanging there, and there's actually a solution that we have developed for cutting the thermal bridge between the balcony and actually the structure by essentially having a separate slab in this case. So as you know, the bottleneck on many multi-story construction sites is actually the stair shafts. So what we've developed is also a prefabricated stair shaft system that basically with the wall shoes that you see at the bottom, it's a module, it's a 1-level module that can just be stacked one over another. So basically we can erect a module like this in about ½ an hour, so your entire frame can still keep going up. You don't have to wait for the concrete to cure. You can set it down and immediately set up a delta beam on it and start erecting a hollow core the next day. So those precast stair shafts are also responsible for the lateral stability of this building. So obviously the whole diaphragm of the floor is transferred to this precast module. And actually you see this angle here, this will be supporting hollow core and basically also tying in the diaphragm to this precast stair shaft. All the forces of this module are taken by, basically the tension forces are taken by the bolts in the corner. So this is secured this way, and basically the shear between the module is taken by a weld that will be done later on in the project. Here we are at the top level of this construction site as of today. Obviously there's another concrete ring going over this stair shaft, and you see that it's a very simple connection. So what we'll have is a bolt projecting on the top of this stair shaft module, and then the next one will be coming down and the wall shoe will just be securing this connection. So it's just a bolt-on connection, and obviously for shear capacity we also have steel plates embedded in the top of the stair shaft, and basically this will be welded later on, but at least for the making sure that the project moves forward, it's just secured with the bolts. So what we see here is actually the lateral stability during construction sites. So we'll see that typically in the corners of the building. So in this case we have push and pull jacks that can operate in both directions. So we can actually push the column out, push it back in, move it to make sure it's nice and plumb. A lot of people ask questions about how we grout the hollow core slabs, how we grout delta beam. So one of the techniques that's been developed is using just a little bucket where you're actually going to be pouring the concrete on top and basically pulling that little bucket directly in the hollow core keyways. And then to take the concrete up to this floor, you can also have all the pipes for the pump already pre-installed. So you just need to connect. You don't need to have a big concrete truck, a concrete pump truck coming to the job site. You just connect here, fill your bucket at the same time as you're filling your delta beam and your composite columns. We are now under the floor that's just being erected. And basically, as you can see, it's nice, open and clean. We just removed the shoring post. So once the floor is grouted, you can essentially remove the shoring post immediately and have the other trays coming right in. We're now on the top of a delta beam that's been concreted. As you can see, this top plate here, that's a steel top plate with the lifting hole that's completely full of concrete. So this entire beam is full of concrete. This is how we achieve the fire resistance of the beam. At the same time, you will see this hollow core slab has an opening for the two number 5 bars that are passed right through the delta beam at every hollow core slab. So here we have the composite column that's now been concreted and a delta beam that's also been concreted. At this point we have now a fire resistant composite column, in this case for 2 hours, and this beam has been tested by UL for 1, 2, 3, and 4 hours without having to fireproof the underside of this beam.
Eliminating the thermal bridge in a balcony is a challenge in many construction systems because the slab is actually partially outside and partially inside. In this case, we completely insulated the slab, the solid slab that's going outside, with urethane. Urethane was actually sprayed on site under the solid slab that is cantilevering outside. And there's also urethane sprayed between the solid slab and the first hollow core slab. So we completely eliminate the thermal bridge. Now on the top side of the slab, what we have is the insulation from the styrofoam that serves to hold the radiant heating system, and then the radiant heating tubes that will provide the heat and comfort for the units.